Hello everyone, I'm misof, and this is the solution of problem G, glyph recognition of NVARC 2017. So, in this problem, you are given the input as a collection of these blue points, and you are to match it to one of 6 given shapes. The shapes are a triangle, a square, all the way up to a regular octagon. So, regular polygons with 3, 4, 5, 6, 7, and 8 vertices. They are all centered at the center of the coordinate system. They are all rotated so that one of their points lies on the positive x-axis. So everything is uniquely determined up to their size. You can scale them arbitrarily. Now, given these blue points, they don't have to lie on any of those 6 shapes. We want to find one of them that matches them most closely, and this is done as follows. So you are supposed to find the smallest size of the shape that contains all of the given points, the largest size that still doesn't contain any of them, and you can then divide those two ratios to get some measure of similarity. And the closer it is to 1, the better the shape resembles the layout of the blue points. So we should do this 6 times, once for each of the shapes, and then find the best ratio possible. So this gives us a smaller, easier problem. Given the collection of points, find the maximum size that contains none of them, find the minimum size that contains all of them. There are 2 possible approaches. One possible approach is to binary search both of these, because as soon as a polygon contains all of them, if you increase the size, it will still contain them. So you can just take the interval between 0 and some sufficiently large size and use binary search to find the optimal size where it already contains all of them. You can then do the same thing for the minimum. Okay, so the only thing we need for this solution is a test whether a point lies within a polygon. This can either be done by retyping a general solution from your code library, or just by realizing that these polygons are all convex, so you can just do the test by doing some simple cross products. So this would be the first solution. The other solution is that we can actually, instead of binary searching the answer, we can compute it directly. It's not so hard. It's shown in the picture here. So whenever you have a blue point, first of all you can find the angle into which it belongs. So from the angle you know which side of our polygon it will intersect. And this answer doesn't change if we scale the polygon. So here the green line is the ray going from the origin through one of the blue points. And as we scale the polygon, then the intersection point will still be on the same side, it will still divide in the same ratio, it will just be scaling, be moving upwards. So what we can do is we can take a polygon of a unit size, we can compute the coordinates of its vertices using just some sines and cosines because we know these angles, and then we compute the intersection point between this line segment and this ray. And by knowing this distance and this distance, we know the scaling factor when the shape will exactly hit the blue point. And now the minimum of those lengths, of those sizes, will be the size of this, and the maximum of all of them will be the size of this, and this is the answer we are looking for.